Alrighty. So I think the last two have gone pretty well. It's not tough stuff, so long as you know left, down, upright, and you can get your X's and Y's straight. Sometimes you might have to do a little bit of underlining or boxes or colors or something like that for it. And as long as you understand that to be a function, special function, something's got to have more than one, or every X can only go to one Y. So we left off with, here you go. Womp. Remember, it does say explain on each of these. So for 9, 10, and 12, since they are not functions, each one of them is going to have an explanation that says something like, this thing goes to these two things, and that's wrong. Yo. Yes. Okay. Dominic got the perfect thing there, exactly what we were talking about. We said that your explanation doesn't even have to be words. If you had done 9 goes to -8 and to 4, like that, I take that as an explanation. Okay? Y'all, I communicate in grunts and gestures half the time. Ugh. So, yes, this works. Ugh. Um, for 11, you just say every X goes to one Y. Or every button only does one thing. Okay. Anything about those? Again, I hope that you're actually doing this, not just BSing it and pretending to do it. Okay. They got a lot of big words down here. Every domain value is paired with a unique range value. We had said you could just say function passes the vertical line test. That's fine. Okay. I don't need a whole thesis for why it works. You know why it works. Pass the vertical line test. Now, big kid words are good. How many times do you get across a question in math or science and you just don't even know what they're asking you to do? Like, it's not even a word problem. You just don't understand the instructions because it's got big words in there or it's got unfamiliar vocabulary. Okay? Y'all don't have to hide back there either. Every other one of my classes, I got kids right up here. Okay? If you just want to be like front row, put on the tarp and bring on the splatter kind of front row, then hey. Um, when you say that this fails a vertical line test, you just have that one line there and you say fails vertical line test. Okay? So the first 6 are just, is it a function? Yes or no. If it is, ta-da! Kind of ironical that I record this too. The very first lesson I ever taught in front of a class full of kids. Very first one. Y'all know how sometimes you get, they're not even student teachers. They're like, it's called sophomore field experience or junior field experience, where they'll have someone who just comes and sits in your class for like 2 weeks and that's it. Very first lesson I ever did. Class full of 5th graders, right? I got stuff set up. In the back, you got the little camera on a tripod, right? Because we have to review our own lesson and critique ourselves. There's a little stool up in the front. Very first thing that I do. Come up here and, all right, and I plop down. The back leg breaks on it. And I go not just backwards, I go backwards and my legs fly up and put a hole in the wall. My foot puts a hole in the wall. Very first thing I ever did in the classroom. Pop back up. And now for my next trick. You do that around a group of fifth graders, they just eating out of your hand. This guy's like a clown. He's going to teach us stuff. Yeah. Sullivan is not the most coordinated person in the world. Okay. Next up, we have blah, 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 blah. Is it a function? Well, even the context of the graph, I know y'all don't like word problems, but if you read through it, would you understand what the graph is showing you? In fact, that's what a good portion of Algebra 1 is about. Cold pizza's bomb. A good portion of what Algebra 1 is about and why it's a requirement for everyone is because to be an informed citizen, you have to know how some basic math works, and you have to know how to read a graph. Okay? You see the axes on it, and it says, this many days of school, this many kids absent. So each of these dots represents on the fourth day of school, there were 3 kids absent. On the second day of school, there were 5 kids absent, and so on and so on. The words of it tell me that. The number of students absent for the freshman class at this high school for the first 5 days of the school year. Okay, you need to be able to read a graph because, especially, I teach Algebra 2 and pre-calc, and we do a lot of stuff with stats in there at the ends of the classes. I tell them, y'all, numbers don't lie. Numbers cannot lie. Math does not lie. But people will use numbers and math and graphic representations to misinform you. Big time. Okay? Like the running joke is, 85% of people. So, first of all, 90% of all statistics are made up. Second, there's a new study that shows that 85% of people will believe anything you say so long as you start it with a new study shows. There's like 2 people in here who got that. 90% of all statistics are made up. I just pulled a number out and said, here you go. 85% of studies show 85% of people are going to believe whatever you say so long as you say studies show. I made all of that up. People will use numbers to lie to you. Okay? That's why we have to know all this stuff about math and graphs and junk. Each of these asks if it's a function or not. Here I got a graph, I just do vertical line tests. Here, I check. I press the 8 button, I got a 50. I press the 8 button again, I got an 80. That's all you have to say. Just like Dominic had. You could just say 8 goes to 50 and 80. Not a function. That's all you need to do. Okay? The vocab, there were a handful of you that were a little bit skittish on the vocab until I said, hey, go look at the first page. Remember, it's always right there on the first page of the lesson. A little box off to the side that tells me my vocab. A mapping relation has 5 number values in the domain and 6 in the range. Can you tell me if that's a function or not? And if you don't know, try it. Put 1, 2, 3, 4, 5 numbers in the domain. Put 6 numbers in the range. Try to connect the dots. Try to cross the wires to use all of your domain and range. And see if you can do it without ever doing a Splitsville. Even if you just straight went 1 to 1. This, You're not going to get to your last element of your range unless you do one of these. There's too many range values for my domain values. So that means, no, this can't be a function. Otherwise, I'm not going to hit all of those numbers. That's all this says. If there are more range values than domain values, it can't be a function, because you'll never get to all of them without having one x that goes to multiple y's. Okay. So, where's the thing? Where's the thing? Now I'm genuinely concerned. Where'd the thing go? Is it an assessment? Why would I put it in there? Yeah, it is. What a doofus. But I'll do the same thing to you that I did to Elise. Alright. Boy, Frank, running slow today. There we go. Functions. There you go. You have three different ones. You have a graph, you have a mapping, you have coordinates. I want you to tell me, remember, put 1,6 functions, actually label this for your daily check. Tell me what you're doing, 1,6 functions. And then for these three things, no, you do not have to copy them down. If copying it down helps you, great. But you don't have to copy them down. You just tell me, like, A, yes or no, why. B, yes or no, why. C, yes or no, why. All right? So you got three of them. You tell me whether it's a function or not and what your reasoning is. And I poked a button. Let's see how we did. Round one, I just do a vertical line, a vertical line, a vertical line, a vertical line. Frank draws them 3 seconds after I draw the vertical lines. And we ask, does it pass? Yeah. Now down here, it might start to look like they're curving almost straight. Okay, I don't know if you have seen these before. It's called a parabola. It's very, very important type of graph in high school math. We are even going to get them in here a little bit. It's not straight down. It doesn't curl back in on itself either. It just starts going so fast and so sharp that the curve is tiny. But it's still curving, so it still passes vertical line test. So I would say yes. And honestly, that can be my reason. I can say passes vertical line test. Or if you said every x goes to 1y, something like that. Okay? Contestant 2, yay or nay? Nay, because that is not a function, because -1 maps to both 4 and 5. And you can even just write that. -1 maps to 4 and 5. I suppose another arrow would help, right? Contestant 2. Wait. 3. I can count! Is what? Also an A. Because, why? -3 goes to both -3 and to 4. So, here's what I'm looking for. It's still out of 5. When I do this, some kids freak out. It's still something out of 5, but I'm just going to say 2 each for the yes or no and the reason. And if you got all 3 wrong, everything, you just deserve like a 1 out of 5 for getting them all wrong. Okay? So, for example, if you said no, but you instead said 2 things go to 5, okay, you get 1 off for the reason on it. If you had said yes, but didn't have a reason at all, that's 1 off. If you had said yes, every x goes to 1y, you completely missed the point of the lesson. That would be 2 off. Okay? So 1 for the yes or no, 1 for the reason, and then, and y'all, if you're at least trying these, if you are attempting them, if you do something besides just write the problem, you're never going less than 1 out of 5. I've seen a couple of you giving yourself a 0 because it just went horribly, horribly wrong. No, you at least have 1 out of 5. You at least tried to do the thing. In fact, I've gone back over some of yours and I've turned that into a 2 or even a 3 out of 5 because no, you didn't screw up nearly as bad as you thought. But then I've got others who will screw up horribly and they'll write a 4 or a 5. I'm like, no, that ain't it either. Okay? If you're not sure, you can always ask. I'll just look at it and tell you what to put. Okay?
So you know how you said there were 1 for, so I just put 1 or would I put 2?
The -1 goes to both of them. You got it.
Should I put 1?
No, this is right. You got this.
Should I put 2?
You said it's not a function because it goes to more than one number twice. Okay, so we swapped up our vertical horizontal. I would say you have a reason. It just didn't match the graph. I'd say 1 off there.
Okay.
Okay. And this one, I would say 2 off there because it didn't even have a line.
Should I put 2 or 1?
Put 2 out of 5.
2 out of 5.
There. Okay. I just don't know why I erase it when I'm just going to get rid of it anyway. Go to 1-7. Does everyone have their calculator? Okay, I said you need a scientific calculator at the least. The graphing calculators that I have in this class, I probably use more than anyone else in the building because of pre-calc. They are exponential overkill for what we're going to use them for. All right, these things will almost do your taxes. The only thing that you really need to use them for is the basic arithmetic, the parentheses. We use them for some pretty wicked stuff in my other classes. I would like everyone to please reset them because Algebra 2 just took a test. No, you do not just flip it over and stab it in the back. In fact, all of that graphite being stuck on the button back there from people stabbing it in the back over and over is what holds the button down and eventually doesn't let the calculator turn back on without me prying these things open and cleaning it out. Instead, we got a little mantra. Second plus 7, enter 2. Second plus 7, enter 2. Second, right above plus is memory. Option 7 resets it. Enter. Oh, okay, plus 7. Enter, because yeah, I want to reset the whole thing, and 2 is just, yes, I'm sure I want to reset it. Okay? Because you don't have the graphing calculator, I'm telling everyone to do. Killing me, Smalls. Okay? Second plus 7, enter 2. If you want to reset it, you can. Yours is just second right above 0. Okay.
Okay.
Those, personally, I believe, if you are never going to go past pre-calc in high school, I think that's the best calculator you can possibly have. It's $18 and that thing does stuff that even the graphing calculators won't. It it is really good. Okay? So, yep, second plus brings up the menu. 7 says reset. Enter on the all RAM says, yeah, I'm sure I want to get rid of everything. 2 says, like, it gives you, it's like, you have to have 2 keys turned at the same time before you can launch the nuke. It has the different parts of here to say, are you really sure? Because if you get rid of everything on here, there's a lot of downloadable programs that we can have on here. Even the old TI-83s, when I was in high school, I programmed Monopoly and Zelda on there, like Link's Awakening from Game Boy. I had that on my TI-83 in high school. Okay. People can put a lot of cool stuff on here. You can have a lot of data, a lot of different programs, and it keeps asking you, are you sure? Because if you do, you get rid of all of that. Okay? So now, everyone's got a calculator. Great. I want you to hunt around on here and tell me, where are my parentheses? Like, I want you all to be able to type 2 parenthesis negative 4 parenthesis squared minus 1. I want all of you to be able to type that on your calculator. This is why I said the phone calculators aren't going to work. Okay? Everyone should type this, and everyone, it should say 31.
What? I typed in the right thing.
What? No, 16 squared, 32, so 5, no, it's 31.
Bro,
Okay?
oh, that's a minus.
I want you to think about, you monkey around with your calculator until it says 31. Okay? There are different buttons on here. One is a negative, the other is minus. Those are 2 different things. Okay? 2 parenthesis. The negative is down here. 4 parenthesis. There's a special button for squared because it happens so often. If you ever want to go bigger than that, you hit this caret button, and most of us should already know that from our exponent stuff. And then minus 1. Okay? I want you to look at the difference in sizes and position of the negative and the minus here. This is what happens when you get a scientific or higher calculator. It's going to be a little more complex. Watch what happens if I say 2 parenthesis and I try to use this. Minus 4 parenthesis squared minus 1. This says minus. This says subtract. You are asking your calculator to subtract 4 from a parenthesis. Your calculator is going to say, dude, what? Okay. And the more complex calculators, they will have error messages. The error message does not just, my calculator told me to quit. That's really discouraging. I should just give up on math. It will tell you what you did. You just got to know the vocabulary. Check all arguments entered. That means you type something dumb. Okay? Like, use that on someone. When you're arguing with someone and they're just being a total bonehead and they say something that makes no sense, I want you to just look them dead in the eye and say, check all arguments entered. It means you said something really stupid. Okay? It means you typed something goofy. Addition. Syntax. The word syntax. I don't know if any of you have heard that outside of the explosive, probably from a game. Okay? Syntax is like there's grammar and then there's syntax. Grammar is how you said it. Syntax is what you said. Okay? Like Yoda has interesting grammar and syntax because his grammar is he changes the order of his verbs, nouns, and articles. The syntax is sometimes he'll just straight up use a different word because there's no conjunction in between them. This message says, you type something weird. Dude, you can't say that. Check out option 2. It says, go to. If I poke that, it'll even bring me to exactly where I screwed up. And look at what it's highlighting. Okay? I switched to the negative and look how it changed. It went from big middle line to little above line. And now I'm good to go. Where I put that also matters. If I say 2 parenthesis negative 4 parenthesis squared, if I use this button again and then 1, that says negative 1. And what happens when I smash something up on parentheses? So this is now going to take negative 4 squared is 16, times 2 is 32, 32 times a negative 1. It is not going to give me the correct answer because I did not type it in correctly. Okay. Additionally, on this first page of 1.7, I want you to write it down so you got at least somewhere to look back on it. If you are using my graphing calculators in class, the number one thing asked in any teacher in any math class, they come bring the calculator to you and they ask what? How do I do a fraction on here? Over and over and over. Okay, if you're using my calculators in here, they are more complex. Hit alpha. This entire top row has shortcuts for stuff that we do in upper math. And if you poke the y equals button, the very first menu of shortcuts is fraction stuff. You don't have to worry about it because you just got a button that says box over box. It's perfect. Okay? I want a fraction. I'm going to do thing over thing. And I even got a box over a box, literally a button that says thing over thing. It's perfect. Okay? For us, don't we want box over box? So you just enter on option 1, and now you can type fractions. But you have to use your arrows to say where I want to type. Okay, alpha y equals brings up your fraction menu. I got to say all this stuff because we need these calculators. I am not going to make you do the heavy lifting yourself. Do you remember graphing by table? From a couple of hangdog expressions, I'd say some of you remember. Okay. Graphing by table, just like I can always write things out for exponents when I'm stuck, I can graph anything by table. You might not want to, but you can do it. No, not the select button. There we go. Okay. We are going to start graphing equations. An equation has a equation equals symbol in it, and now we got more than one variable. We got y's and x's. That's why we started with relations and functions. A relation is a mapping, x's to y's, input to output, domain to range. Functions are special ones. We're going to start graphing functions. And just like you did last year, we're going to start with tables because It doesn't matter what the function is. It doesn't matter what the equation is. It doesn't matter how butt ugly it is. I can graph anything with tables. But how many of you want to put in, -4 times 1/2 plus 3? Find it. -1/2 times -3 plus 3. How many of you want to do that over and over and over by mental math? Okay, how many of us can do that by mental math? Okay, sometimes just basic numeracy doesn't work for us. So the way that we're going to do it is with our calculator. If I have y is 1/2 x, why are you blinking? Do be frank. Okay. Everywhere that there, why are you blinking? So we're going to type 1/2. So alpha y equals. I bring up a fraction. I put a 1, I arrow down, I make a 2. I arrow over to say I'm done with the fraction. And now I'm going to plug numbers in. I'm going to plug in a -4 with parentheses. And then plus 3. This is why I want you to have a scientific calculator. This is why I've spent time in class talking about the calculators. I don't want you to do this by hand. Okay? My job is not to teach you how to do arithmetic. My job is to teach you how to do the algebra. Here's a tool to help you with the algebra. Okay? And I hit enter. Here's another reason that I wanted you to have these. Every one of you, yes, including you, Emily, your calculator is going to do this too. I want you to arrow up. If you have done this, arrow up and highlight that thing. Hit enter. Now you don't have to type it every time. You just go back and change that -4 to a -3. Because use your arrow buttons, go up and highlight the thing that you did, hit enter, and it'll type it again for you. Yeah, it does.
Like that?
Yes. Then you hit enter.
Oh, wow.
Now you can go back here and change that to a -3. Then you can highlight it. And you go back and you say, I'm going to be a -2. This way, instead of typing it over and over and over and over, it's, you now have calculator copy pasta. Okay? You go back and you say, this is going to be at -2. And then you go back and, this is just to save you time. You can do this on your phone calculator. You would do 1 divided by 2 is, times -2 is, plus 3 is. You'd have to keep hitting equals and doing the order of operations. But now I'm just showing you the shortcut that's going to help you get past this. Maybe I delete that out and I just put a 0. Okay? And that's how you're going to get your tables. Come on. Come on. This table here, I'm not going to have you do them by hand. Okay? I want you using the calculator and the tools to make this go faster. You have the fastest thumbs of any generation in humanity. You spend all day on your phone. I'm looking at you, Clayton. Okay? Do you know how to use the calculator? Can you type stuff in? Can you put a fraction in? Can you use parentheses and negatives and positives? Do you know where your squared button is? Do you know where exponents are? If you know how to use it, then graphing these is going to get real easy. You have an equation, you pick your x's. You plug the x's into the calculator, you get the y's that go with them, and now, do we need to put this next to it so we don't screw up our graphing? Frank, yep. Okay. Hey, I'm on a new page. I'm going to be graphing stuff. Maybe I should put that little cheater on there so I don't screw it up. So when it says -4, 1, I look at my little cheater and it tells me I'm going to go put a point left 4 up 1. Left 4 up 1. This says left 2 up 2. Left 2 up 2. No left or right, up 3. Right 2 up 4. Right 4 up 5. And then I'll connect the dots. A lot of the stuff that we're going to graph are going to be lines. Y'all need to use a straight edge. Don't wing it because I've seen some of your handwriting. Okay? No, you don't get to just wing it. Use a straight edge. At the very least, y'all should have your ID on you, right? ID, driver's license, debit card, Qdoba gift card. You got something, okay? Honestly, when I do, I just yank this off my belt and I make my straight edge, okay? I do this or else I'll forget where it is at all times. So that's it. That's what we're going to do. We're just going to practice a lot of it. Frank, why are you so slow? The entirety of 1-7 is just, hey, I want you to graph this thing. So the very first option that they give us is, okay, they already gave us a table. It's already there. Can you plot the points? Remember, X, left or right. Y, up and down. Plot your points. Connect the dots. I've even had kids where they say, all right, if X is left and right, I'm going to put next to this left, left, nowhere, right, right. Up, 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 nowhere, down. I've had kids put that next to the table. If you're one of those that's going to goof on left, right, up, down, and that was a big problem last year, write that next to your table. Okay? If you don't need to, you don't need to. But boy, does it help if you need it. Okay? So each one of these points goes on here. I'm going to go left 8 up 3. Left 8 up 3. I'm going to go left 4 up 2. No left or right, up 1. Right 4, no up or down. Right 8, down 1. Go get yourself a straight edge, connect the dots. Okay, that straight edge, I've seen kids use just the edge of the calculator, edge of their phone. But you should have at the very least your ID on you. Okay, and I connect the dots like so. I can't put a straight edge up there because as soon as the straight edge touches the board, it thinks it's my marker. Okay. So the first one is just, can you even plot the points correctly and connect the dots? After that, we're going to start by the table. And this is where they show us, this is how we're supposed to be making the table. This is how you did the table last year. You pick the points, you plug them in, and you have to show your work for every one of them. We're going to go faster than that. Okay, boat rental. allows customers to rent a boat for $50 plus $25 an hour. So if you just wanted the boat and then you changed your mind and never left the dock, well, you had it for 0 hours. I take 25 times 0, 0, add it to 50. So that tells me I'm going to have a coordinate of 0, 50. And then I plug in a 1, and I plug in a 2, and I plug in a 3. And especially when I have lines like this, where there's no x squared, it's just y's and x's and numbers, that's it, you're going to start seeing a pattern pretty quick. And you can usually just fill in the rest of the table with the pattern. So $25 plus 50 is what? $25 plus 50. $75. What's 2 by 50 or 2 by 25? 50 plus another 50 is 100. And you start seeing the pattern, right? 50, 75, 100. What's next? 125. Okay, 50. So if I want to rent a boat for 3 hours, I have to pay $125. And if you've ever seen how bills work for places like this, like this time of year, usually a lot of folks will try to turn their heat on for the first time and it doesn't turn on. Oops. Okay, if you don't know how to service it yourself, you got to call someone from heating and cooling. Guess what? They're going to charge you about $80 just to drive out to your house. And then it's going to be something like 60, 70 bucks an hour. And what do? They open up the front of it. Yep, your pilot light's out. I'm going to clean this sensor real quick, light it, turn your heat on. That'll be $184, please. And they laugh because it doesn't matter whether they were there for 10 minutes or 59 minutes. They're still charging you for an hour. Okay. No joke. You want to make money? You go work in HVAC. You go become a certified welding tech. Okay. Be a plumber. Plumbers make way more money than I do right now. And they're short-handed. Okay, so we said 0, 1, 2, 3. We had 50, 75, 100, 125. Go plot your points. At 0, 50, make dot. 175, make dot. 200, make dot. 3, 125, make dot. And now that I got dots, I can connect dots, make line. Notice I didn't make my line go all the way to the left. Why not? What kind of numbers are to the left of where I started? Negative. Can you rent a boat for negative 1 hour? No. What even is that? I'm going to let them borrow my boat for an hour? It doesn't work that way. So I'm only going to start there. And then it asks, find the value of c of x. C of x is the name of our function. When x is 5. So I'm going to go to 5, go up and hit my line, come across, and I see 175. I could have also just come back up here and said 50 plus 25 by 5 and gotten 175. That would have worked too. 175 bucks for 5 hours. And then when you start thinking about it, if you got 5 hours out on Pactola with a boat, for 175 bucks? That'd be a deal. I think the marina down there would probably cost you more like 400 or 500 to rent that for an afternoon. It's also why I don't understand people who have boats. Like, how do you have that much money just laying around? Okay, so try it. Here's a table, plot points, connect dots. If you need to write that XY cheater right above this, so you don't goof up left, right, up, down, write it. I also want you to be very, very careful. Look at the y-axis on this graph. What are they counting by on those boxes? Okay, so when they say I want you to go to 0, 5, where do I got to be? In between. I'm halfway through the box. I think that y'all are going to be fine just plotting points and using the calculator. But the scale on some of these graphs, every year, scale is what messes with kids. Okay, I like that I see some of you who are putting the arrows next to the table. That'd be really good for helping us with our graphs. Now, for some reason, kids got this stigma of, well, I'm not going to do that. That's dumb. Or that's childish. Or I don't need to do this. Y'all, I'm the math teacher. I'm fairly intelligent. I will still count on my fingers. And I'll still get it wrong, as evidenced by all the brownie points that kids are wrecking me with. Okay? Use the tools. Tell yourself that this is left, left, nowhere, right, right. Tell yourself this is down, up, 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 up. If it helps you, use it. If it doesn't, don't. Go make your dots. Left 4, down 3. Left 4, down 3, be careful, is halfway through the box. Their scale is going by 2s. Left 2, up 1. Left 2, up 1 is again halfway through the box. If that messes with you a little bit, another thing you can do when they go by 2s like this, come back to your y-axis, just put a bunch of little tick marks in there halfway through to remind yourself to count twice per box. Works for some. You don't have to do it. It's just another skill. And I keep going. I say no left or right, up 5. Put point. Right 1, up 7. Halfway through box. Right 2, up 9. Halfway through box. If I did it right, they should all be on the same line. I'm ready to make my line with a straight edge. Hopefully I don't suck. Okay, use the edge of a binder. Edge of your phone case. You're one of those kids that's got 15 different pens and pencils next to you. Use one of them as your straight edge. Okay? So the first thing is I can plot points from a table. The second thing is I can make my own table. Now, I had a couple of you in Algebra Half last year, and I know that we got really good at recognizing the pattern in the tables. After only 2 or 3 points, we're like, okay, I got it. So, Here's my equation. I'm going to pick numbers to put in. Now, in this case, they're picking the numbers for us. Later, we're going to have to choose. So I'll put in a -1, a 0, a 1, a 2, a 3, and a 4 everywhere that there was an x. I'm replacing it. That's why it's called a variable. Its value can vary. I don't know what it's going to be. What if it was a 0? What if it was a 3? What if it was an 11D blue? You put in numbers, okay, at least we're listening, and then let the calculator do the work for you. Type -2 parenthesis -1 parenthesis plus 6. And let the calculator do the work for you. Would I prefer that you could do -2 times -1 is +2, +2 plus 6 is 8 in your head? Yes. Do you have to? No. Just press buttons. Okay. And then on these, you can just highlight it. Whoop. Right next to these arrows is a delete button, so I'll just delete that negative out of there and turn it into a 0. And then I'll highlight it. And I'll go back and I'll turn that 0 into a 1. I'll let the calculator do all the work for me. I'm just writing it down. Okay. And then I get 6. And then I get 4. And we're starting to see the pattern. It was 8, then 6, then 4, then 2, then 0, then -2. And that should look familiar. It's going down 2 every time because, do y'all remember slope? For every 1 I'm going to the right, it's going down 2. We'll talk about slope later. Right now it's just in a table. You just let the calculator do the work. Okay? Go plot your points. If you need to, again, say left, nowhere, right, 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 up, 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 nowhere, down. If you need to do it that way, you go ahead and do it that way. If you don't need the arrows, don't use the arrows. Plot your points. Okay. Where do we go out to 4? Plot all your points. Sure looks like a line to me. Connect your dots. It was straight-ish until the end. That's why you want that straight edge. Okay. So, sometimes they give me the table, sometimes I gotta make the table. Good. Don't want to poke the thing if we need the thing. Anyone? Okay. All right. Then down below that, one of them, they give me the table and they've already put things in. You just gotta find the numbers. Yes, there's fractions there. I showed you where the fraction button is, didn't I? Alpha y equals for most of you. Box over box for some of you. I can type -8 parenthesis. Oh, wait. It was the fraction thing and then the negative. Okay. So I'd say alpha y equals gets me a fraction. We'll say 3 over 4, then a parenthesis, -8 a parenthesis minus 2. Let the calculator do the work for you. Okay? So, get them. Okay, let the calculator do the work for you. If you need help, ask. We want to make sure that we are doing this right. Y'all, not every teacher is going to let you use the calculators like this. Most Algebra 1 teachers, in fact, are kind of a stickler about this. Most Algebra 1 teachers won't let kids have calculators at all, which is just jerk mode. Depends on the professor. Like I had a kid last year who did college algebra online, and I proctored their tests for them. Every one of their tests had this big sheet of instructions in the front that said the only calculator they were allowed to use was the old TI 30X2S. I don't think I see anyone who has it. Do I have one? Yeah, there we go. Y'all remember these from middle school? Less than that. I think you can get these for like 8 or 10 now. College professor put on his instruction sheet, this is all you were allowed to use. Specifically this. If you couldn't find this, you don't get a calculator. It all depends on the teacher. And I'll tell you, when you get to college, there's a lot of math professors that are just really, really grumbly that the co-eds don't want anything to do with them anymore, so they take it out on students. Okay, if you need help with pressing the buttons, just ask. And remember, you don't have to keep typing it over and over if you do that highlight trick. Arrow up, up, highlight the thing, enter, and it'll just spit it out for you again. Okay, let the tool do the heavy lifting for you. I got to go bust up an old set of concrete stairs in front of a house. We're replacing it with a deck. I am not about to go out there with a 10-pound sledgehammer and just beat the snot out of it for a few days. I'm going to go get a jackhammer. Okay? You use the right tool for the job. I want you to use the calculator so you don't have to break your brain doing the arithmetic. Yeah.
If I want to put an X in for the fraction.
You're not putting an X. You're putting the numbers.
Oh, I see.
Now, there is an X right here, but that's used in formula work. If you were to put this X right there now, it's going to take whatever the stored value of X is from the last time someone messed around with the calculator and shove it in for you. And it ain't going to be -6.
Okay.
So instead, we want to poke, delete that. We'll say, oh, -6. There you go. And hit enter. Oh, yeah, you had to get rid of that. Delete. So you can, here. Okay, I probably shouldn't press it when you're pressing it. I'll stop. Arrow up, up. There you go. You have to highlight this thing, then hit enter. There you go. -6. Arrow over.
Then just delete.
Delete. Delete. There you go.
Oh, I see.
There you go. That's what I want. I want you asking. Yeah.
Did I do this? I don't know if I did that last time.
Well, one of those points doesn't really line up with the
Oh,
others,
that's
right?
that.
So, got -3/4. Moves 5, going down 3, down 3, down 3, down 3. Okay. This guy's off. Let's try this one again. So you do, yep, just highlight that thing and replace that 8 with a 0. There you go. Replace this with a -2.
So that would be down.
-2, yep. So take this dot and move it down here.
This one?
Yep.
Right.
Now these guys were right. Go to 4, 1. This dot that you had over here at 4, 1. Yeah. Now you go and put a straight edge and look.
What's in the corner one?
Well, I don't know where you got 5, 4 from anyway.
Well, I meant to do 8 because there's no room for 8. Those are 8s.
Oh. Well, if there's no room for 8, 4, then just don't do it.
So
Oh, it exists. It's just off. It's off road.
Okay.
Yeah, your cousin takes a 4-wheeler and heads off into the trees. You can't see him anymore. Does he cease to exist?
I don't know. Depends on if he ever comes back.
Okay. My youngest has that problem. If he knows that daddy is home and he can't see daddy, he will just run through the house shrieking. And he just stomps and yells, "Where'd daddy go?" Okay. I have ceased to exist. Poof. Okay. Saw a bunch of us get this. We did pretty well with it. 3/4 of -8 is -6, and -6 minus 2 is -8. I try to plot -8, -8 on my graph there, and I see somewhere out here. It's off-road. I'm not going to plot it. 3/4 of -4 is -3, and -3 minus 2 is -5. Okay, that one I can do. I can go back 4, down 5. Make dot. 3/4 0 is 0. 0 minus 2 is -2. 0 -2 is no left or right, down 2. 3/4 of 4 is 3. 3 minus 2 is 1. I can go make a point at 4, 1. 3/4  8 is 6. 6 minus 2 is 4. But 8, 4 is somewhere out here. It's off-road. So I don't need to make it. But look in the middle of my graph. I still have 3 points, and I can make a line from those 3 points. In fact, you might remember from last year, I hope, that the minimum number of points we usually want to make a line is 3. Because if just one of the points is off, you can't get a straight edge on it. It kind of wiggles around between them. So I can make a line between any 2 points, but I want 3 to make sure my line is on the right path. Okay, this one, did we figure out how to do that with our calculator? So you're going to say y is negative, box over box. You put your 3 here, and this is where you're going to put -6, then -3, then 0, then 3, then 6. Okay? Said that perfectly, Emily. Huh? Get your box. Box over box. Fraction mode. I'm going to say alpha equals womp. Frank's really slow. We have a negative in front of it. This is where the x went. This is where the 3 went. Okay, Dominic had a really good question about this. Says, where's the x? Can I just put an x on there? On the graphing calculators, yes. But that x is going to be whatever the last stored value was. Y'all, I got Algebra 2 and pre-calc. You do not want to mess with the stuff that's stored in these calculators. Okay? That's Pandora's box. That's like when you find out something really, really weird about your parents that I did not need to know that. Okay? Don't don't put X there. You have no idea what you're getting into. Instead, that's where you put that -6. I go parenthesis, -6, parenthesis. Ba-doop boop. And then you highlight it. And you turn it into, what was the next one in the table? Okay. Let the calculator do the heavy lifting for you. My job is to teach you the algebra, not the arithmetic. Use the tools. Okay? Highlight it again and say, oh, negative question mark. Can I do a -0? All right. What's -1 times 5? -5. What's -1 times 12? What's -1 times 0? Still 0. I can say -0 if I want. It just doesn't change anything. It's still 0. Right? Plus or minus 0 is still just 0. Okay? So you should have that pattern, right? Were we starting to see that pattern? 2, 1, 0. What follows? -1, -2. Look at your x-axis. They're going by 2s. Jerks. Okay? They're going by 2s. If you need to put those itty bitty little tick marks in there to help you with this, go for it. Put one there and 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 one there, one there, one there, one there, one there. And within them, now I can count. Put left, put nowhere, put right. Say up, say nowhere, say down, say down. Use the arrows if you need to. If you don't need to, don't do it. It's a tool you can use. Y'all ever seen their special, it almost looks like a filter wrench to open up jars? Like you wrap this filter wrench looking thing on a jar of pickles that you can't get open, and it just whoop opens right up. It's great. But if you have the claws of doom, do you need that? Or can you just Who's the official jar opener in your house?
No one.
Leslie, Dom. Okay.
If I can't
Yeah.
get it open, I just search the drawer for a tourniquet. I bang it on the counter.
Boy, that's dangerous. Okay, because sometimes it'll have pressure seal and that vibration will open up air pockets. Do you know that you can put it into ice water and you can cool it down? Wait, that contracts it. Do I want to contract it or do I want to heat it up? Y'all did physical science, right? Can I put it in warm water?
Yeah.
Run it under a hot faucet, okay, to expand the metal. Another one, just like that filter wrench I was telling you about, there was actually one of the kids in our game club who was in our Discord asking, how do I get this jar open? I work at Subway. Do you have a leather belt? Because if you have a leather belt, you wrap it around there just like it's on a really, really tiny waist with a big sticking out the end. It's just like a filter wrench. It ratchets on there the same way and it has that sticky texture to it, yanks it right open. Okay? A little cross-curricular stuff for you there. If you need this tool, use it. If you can brute force your way through it without putting all the arrows on there, don't. Go back to -6, 2. Back to -3, 1. Back to 0, 0. Interesting. Over to 3, down to 1. Over to 6, down to 2. I've got just enough to connect the dots. Okay? Frank, come on. Yes, I'm going to leave that there. Just to make the 2 or 3 of you that care twitch a little. Okay? 5 and 6, give them a go. Try them again. Let the calculator do the heavy lifting for you. Let the calculator do the heavy lifting. You don't need to do arithmetic. You don't need to do the hard part of it. The standard is you can graph. Okay?
Am I doing it?
Where'd you get those numbers from?
Good question. My calculator.
Just pull a number out of an orifice, toss them in there, and see what happens?
Yup.
You have to choose the x's first. Yeah.
Yes. That's not cool.
Okay. On number 5, what I'm going to recommend for you. See how it's something over 2? Do you really want fractions? Most kids don't like fractions. What kind of numbers can I divide by 2 and not get fractions? Even numbers. So when you put your numbers in x's, pick even numbers. Don't choose -3, -2, -1, 0, 1, 2, 3. Choose -6, -4, -2, 0, 2, 4, 6. Whatever that denominator is, if you don't want fractions, pick numbers that go well with that denominator. Because if you have odds, the odds
That's
are
not
going
an
to
odd. That's an even. Oh wait, that is an odd. Kidding.
get wrecked, math student.
Kidding.
Okay, if you have odd numbers, you're going to get fractions, and I know you don't like fractions. So instead, we like to use nice even numbers. We also want to use stuff on both sides of the graph. So do like -4,
Oh, so you want me to do all negative?
-2, 0, 2, 4. I want positive and negative. That way I can see both sides of the graph.
Okay.
Okay?
Okay.
So Clayton nailed it. Choose even numbers. Do -4, -2, 0, 2, 4. I probably don't want to choose big numbers like 12 because that's not on my graph. I don't want to choose 8. That's not on my graph. What even numbers are on the graph? Use those. Okay, like I said, use the even numbers that are right there on your graph. Use -4, -2, 0, 2, 4. Plug them in. Get okay. On number 6, I bet some of us found real quick that you can't use certain numbers. Don't they get really, really big pretty fast? Like head off the map? Did anyone find nice numbers that work for 6? It's like even 3 doesn't work. It's too big. So 3 doesn't work. Okay, he said I got 2 and 1 to work. Well, if 2 and 1 work, but 3 is off-road, where should I go? Go the other way, right? 3 doesn't work, 4 doesn't work, 5 doesn't work. Go the other direction. Try 0, -1, and 2. It's -2 instead. Plug them in. Let the calculator do the heavy lifting for you. Say 6 parenthesis -2 parenthesis, that's a 9, -7. And even that's way too big. That's off-road. So try it again. I'll say, all right, fine, I'll try -1. That's too big. That doesn't fit. And then I toss in 0. And that doesn't fit. And I toss in 1. Finally. And I toss in 2. And then I get to 3, and it don't work. It's too big. Get to 4, too big. Don't work. Turns out the only things that we're going to fit, unless we start using fractions, are just these two coordinates. 1, -1, and 2, 5. The reason that none of those other coordinates are going to fit is because this thing is a tall, skinny mini. This is a beanpole. Okay? This is Steven after he gets another 3 inches on. Okay? How tall's your parents?
6'1" and
Yeah.
5'8".
You're probably about there right now. I knew a guy during his sophomore year, he grew 6 inches. I want you to think about that. 1 year of high school, 6 inches. That's not healthy. Like, literally, it's not healthy. The dude had back problems because of it. Because he grew too fast and his musculature and his bone structure couldn't keep up with the additional mass. Okay. Oh, and then this one. Completely forgot that. Okay. -4, 2. -2, 3. 0, 4. 2, 5. 3, 4, 6. Connect dots. We got them? Okay. It's a good place to cut it off. What we'll do is on Monday, right? Yeah, Monday, when you come back, because we got another 4-day week next week. When you come back on Monday, we're going to do that very last problem, just as a refresher, and then you'll have time to work. I said, I don't want you to have homework in this class. Okay?